So our next speaker is Tomas Edso. He's a senior principal engineer at ARM. He's currently acting as hardware technical lead in the ARM machine learning group. He has a wealth of knowledge within video standards, digital signal compression, and signal processing. For the latter years, Tomas has transitioned into the machine learning group with ARM, where he has been part of designing as well as defining and scoping ARM NPU products. So I hope that you've seen the recent announcement from ARM and you will have all the details today. Thank you, Tomas.
Thank you very much for that nice introduction. Yes, as you may be aware, ARM recently introduced a set of new IP, specifically targeting energy-efficient on-device processing for the next generation Endpoint ML, and I'm very excited to be able to share more details today on this set of IP and also the tools and frameworks involved. And at the end, I'll also share a little bit about a use case analysis showing the benefits of this IP over existing solutions. But first, I'd like to share a little bit on ARM's view on the AI platform. AI is really transforming computing everywhere. And AI really started out in the cloud, and that's where you see the big training and data sets and all the heavy compute. But recently, there has been a shift of training and inference to the edge. And here we, by edge, mean sort of servers and gateways and at the edge of the network as such. But we think the really big volume and the really billions of devices are really going to be at the very end point, and that's obviously what this conference is about. And that is also where this IP that we now announce is targeting at. So the IP that has been announced are the Cortex-M55, which is designed to be the most efficient and AI-capable Cortex-M processor. And it is the first one which has support for the Helium vector extension set. And that was actually presented here last year by ARM at this conference. With this Helium vector extension set, you will get a 5 times DSP uplift and a 15 times ML uplift, and that is for the multiply accumulate parts of ML, where the Helium vector extension set has specific instructions for that. Also announced is the Ethos U55, which is ARM's first micro MPU. That is an MPU specifically designed for embedded constrained systems. And that one has been designed to be paired up with the Cortex-M processor. In fact, it doesn't have to be the Cortex-M55, but if you want this balance between traditional ML technologies and DSP and pure raw neural network power, this is an ideal combination. So with the Ethos U55, you can get an additional 32 times uplift on the neural network loads, and together you will get a 480 times more performance for your neural network load compared to solutions existing today. They are both very scalable and configurable. So for the Cortex-M55, for example, it also supports the ARM custom instructions, allowing you to configure your Cortex-M to your specific needs, should you have such. Also, apart from that, the Cortex-M55 is configurable in many other ways. It's very highly configurable. Ethos U55 also configurable from 32 to 256 multiply and accumulates per cycle, giving a large range of configurability for any type of use case. And the third IP at the bottom also announced is the CoreStorm 300 reference design, which is a sort of pre-built reference including these two IPs, interconnect, power and clocking, control and other things that makes it really easy to fast get into the market with this IP. And one of the big benefits we see with this combination is also once it has been deployed, I mean, it's possible today to pick IP and build a similar system with existing IP today with sort of a similar performance. But once deployed, you will be in the problem of having easy deployment on software on those platforms. So if you pick 3 different IP, you will probably have 3 different tool chains, different debug. It's simply quite difficult to get fast and easy deployment on such a device. Whereas we think there's a big benefit in having this combination in that the DSP embedded, they share the same code, same debug, same tooling. And also now with the Ethos U55, as you will see later, you can seamlessly accelerate your neural network on the Ethos U55 in a very unified manner. Also, security is very important. And Ethos U55 and Cortex-M55 have both been designed for the trust zone and work seamlessly together in a secure way, whereas the solution to the left is probably going to be some afterthought, whereas Cortex-M55 and U55 have been designed from the beginning to be secure. So let's take a little bit more look at the Cortex-M55 processor. As I previously said, the big thing here is that it is the first one with this helium vector extension set. It's very energy efficient for vector processing. And like I said, up 5 times the DSP performance and 50 times ML performance compared to existing M4, I think it is in this case. It's capable of any kind of compute, obviously. So if your AI application is a mix of traditional style ML and NL, this will work for both. It also has the AXI interface because using ML, it's all about having efficient data traffic. So it's been designed for very efficient shuffling of data. And as also said, it's trust zone certified, making it easy to get your platform certified for security. Also, to make it even simpler to deploy your solutions, there's a software framework on top of the Cortex-M55, or in fact all the Cortex-M. So there are libraries available that are provided for free. There is one library called CMSIS DSP, which targets these traditional ML techniques and traditional DSP. And there's the CMSIS NN neural network library, which is targeting specifically operations that convolution, depth-wise convolution, pooling, and other things that occur in neural networks. This is, again, to simplify the deployment once this is out in the field. And it's also regularly updated on quarterly basis. And here is an example of that. The status quo, the current one, is that if you run a MobileNet V2 with the CMSIS NN here, we currently see an 8 times uplift over the reference kernels, and a 10 times improvement on wave to letter. And this is just right now, it's continuously improved as time goes on. And maybe a little bit more unknown to most, this is more about Ethos U55 micro MPU. So the Ethos U55, it is designed to work alongside with a Cortex-M type processor. Like I said before, it doesn't have to be the M55. It could be any M class, preferably one with AXI, again, for simply machine learning needs a lot of bandwidth and data. So that would be M55 or M7 to be the more preferred ones. The other ones you would ideally bridge over to AXI and have Ethos U55 on the AXI. The system that Ethos U55 is designed for is a system containing a system SRAM, typically on-chip, and a flash, which could be either on-chip or off-chip. In fact, you can run without one as well if you can fit your entire model in an SRAM. But this is the type of system it's designed for. The Ethos U55 will accelerate all the popular networks, all CNNs and RNN operators, so tanh, sigmoid, element-wise, pooling, depth-wise, etc. All the things that occur in neural networks. It has weight compression, and this is really important. This is to lower, it is to fit with constraint system. It lowers power. It speeds up execution, and I'll show more later on what that, the kind of compression we can achieve. It supports 8 or 16-bit activations, signed, unsigned, but weights are always 8-bit, but since compressed, if it was quantized to something less, it would be, the compression scheme gains from it, so you get the full bandwidth benefit of having less bits in your weights. And again, the scalability from 32 to 256 multiple accumulate per cycle. So how does it work? So this is an example of the data flow in Ethos U55. So typically here, oops. Yeah. So in the beginning there, you have pre-compiled your network and put it in Flash. That's the typical first state. And then, okay, where's the one? Yeah. That doesn't work well. So the Cortex-M then places the input activations in the SRAM in a work buffer. And then the host starts up Ethos by pointing out where the model is and the pre-compiled command stream, just setting up a few registers to the Ethos. And then it starts executing the command stream, the pre-compiled network. And whilst doing so, it uses an internal DMA to completely autonomously run the entire network. And once done, it fires an interrupt to the control. To the Cortex host. In terms of interfaces, it's quite simple. It has a single clock. It has a Q channel for power and a Q channel for the clock itself. And it's worth mentioning that between inferences, there is no state inside Ethos U55, so you can power down immediately after an inference. So there is no concept of idle power or something like that. You can just completely shut it off between inferences. It has two AXI interfaces. One is read and write. It's typically where the traffic goes to the internal SRAM, and we have a second one as well, just for reading from Flash. And the reason we separate that out is it makes integration easier. You can present two addresses, and the one to the Flash is typically slower, so it just makes it easier to get good performance out of the system when you're integrating it. It has a single interrupt signaling when it's done with an inference job. and then the APB interface to set up ethos in the beginning, simply pointing out where the command stream and model is, and the input activations and things like that. So how do you use this then in a real software flow? So I've actually seen other examples of people sharing the same flow here. But currently I've integrated the flow into TensorFlow, or more specifically TensorFlow Lite Micro. So it begins with, see if I can get this to work. You have your network in a TensorFlow network, and you have tooled it into a quantized model, pruned and ready for deployment in a TensorFlow Lite file. You could then run that completely on your system here, and then it would run like any TensorFlow Lite model, and it could use the CMSIS NN models if you have that in your system to optimize on Cortex-M. But what the really special thing here with Ethos U55 is this offline optimization tool to the left. So what you do is you take your TensorFlow Lite file and run it through that offline optimization tool, and it will go through the graph in there and schedule everything that can be scheduled onto the micro MPU as a custom operator inside the TensorFlow Lite. So the tool actually generates a new TensorFlow file that is then actually reduced in size, because every weight that is passed to the micro MPU gets compressed. So you gain in size, and also it gets scheduled such that the SRAM footprint required dramatically reduced. Is dramatically reduced. So I'll show a little bit more on that in a coming slide. Any operator that does not map to the MPU, in case there should be one, just does not get, it gets excluded from the custom operator, and then it runs in CMSIS NN if that is available, or it runs, worst case, as a reference kernel. But everything you feed will run. It's just a question of where. So from the application, it looks like any other TensorFlow Lite file. So a little bit more on this offline optimizer. So it reads the TensorFlow Lite file, identifies subgraphs, as you can see there. The other operator is some odd operator that we don't support. Everything that we support, like convolution pooling, fully connected or something like, gets a custom operator, and it's inserted into the TensorFlow Lite file. And the TensorFlow Lite file parser will automatically just execute this, and when the custom operator is found, it will take that precompiled command stream in the TensorFlow Lite file and just point the micro MPU to where that is located, and it will automatically run on the MPU instead. In this optimization of subgraph, a number of key things are done. So operators are fused and run in parallel on MPU if that is possible. You also identify if you can cascade, that's what we call, across several layers to reduce footprint. And I've also seen others do similar stuff. Sometimes you can avoid large tensors by sort of cascading across several layers until the tensor becomes small again. And we are seeing that with this offline optimizer, you can reduce the SRAM footprint for popular models about 90% by doing this kind of cascading. We are also seeing that the compression of weights reduces the size of the network by up to 70% by using sparsity and what do you say? Clustering and other kinds of techniques. And we think this is really key. This is enabling, in constrained system, it will enable networks that was simply not feasible to fit into these systems before. So not only, we accelerate the max as such, we also make the model smaller and possible to run in embedded systems. Now I'm going to talk a little bit more about some use cases we have run through. This is actually using the use case we used where we are using the 128 MAC Ethos U55, and here we can see some rather impressive improvements over Cortex M4. Web2Letter runs 230 times faster, MobileNet V2 150 times faster. A little bit more look into this smart speaker use case, because I think it highlights the value of having both the Cortex M55 and the Ethos U55. So if you just look at an example smart speaker pipeline, it is actually a mix of green boxes here, which is sort of traditionally done with classical processing. Sometimes it can do with a neural net as well, but normally classical DSP processing. And other parts of the chain, like the actual speaker verification or automatic speaker recognition. That's always sort of neural nets. So in a true application, you have a mix of DSP and neural networks, and that is a little bit of a fuzzy line as well. It changes. Typically, classical DSP algorithm gets replaced by neural nets as progress is made on neural networks. So if you have both, you are free to change. You can sort of follow the front of AI. Another example of the opposite is that maybe in the future some neural network inserts some strange operator that was not present when we designed U55, and with this flow you just recompile, and that operator will be then scheduled onto the Cortex M55 instead, so you can still follow the neural network front, and you may optimize that, or we may actually in fact optimize that kernel for CMSIS NN as time goes on. So it's a flexible solution, we think. So some numbers of what can be achieved here. For this smart speaker use case, there's a 2-microphone beamforming and some other operations, and a keyword spotting at the end. So let's say you have a system with only the Cortex M55. You would then get a 70% reduction compared to M7, so 30% of your time. Now let's say you want to add ASR on top of that. So you add Wave2Letter to do the ASR. That simply becomes too heavy even for the Cortex M55. That doesn't work. Then you combine it with Ethos U55, and it becomes feasible again. In fact, you can run Web2Letter in parallel as well, because that network maps perfectly on Ethos U55 without any intervention. So this is then showing, the numbers before I was showing that were higher, they were for the pure neural network loads, like you could get this 480 times. That is true, those numbers are in fact possible. But maybe this is a bit more true in the sense that this is the full application. So this is the kind of uplift you get, including all the pre-processing, etc. So we are seeing a 50-time speed up using a combination of Cortex M55 and U55 on this smart speaker use case. And the power and the energy efficiency is 25 times better. And as you can see, for some solutions, there is the middle ground of just having the Cortex M55 again. That could be possible for some scenarios. So summary. I mean, there's not just ARM involved. As always, ARM has a very extensive ecosystem of partners, and the feedback we're getting on this product lineup has been great so far. Together with all these partners, we're making sure that all the tools, software, OSs, etc., supports this combination of IP. And together with the lead partners, we're going to bring this into Silicon in 2021 in mass production. So again, a summary. ARM Cortex-M55 and the ARM Ethos U55, we really think will bring the benefits of AO to these billions of devices to come in this endpoint space of ML. We think we have really good performance, a simple and secure software development, and together with all the ecosystems, we think this could really get into the hands of developers and enable this AI revolution on the endpoints. So if you want more information, you can also go to the ARM table outside, where I think there's more documentation and for you to read and look at. So with that, thanks a lot.
Time for questions?